So let's start with this today. Solving linear systems substitution method. What we're assuming here is, before we go on, when we say we're going to solve a linear system, we're assuming that we have two or more lines. That's what makes it a system. And that we believe that our two lines meet somewhere. So I'm not suggesting that this is one of the lines and that this is the other one, but I'm saying that, you know what, let's do it this way. Let's say for a second that I believe that the orange line right here maybe looks something like this, and the gray and this equation right here, if I graphed it, would look something like this. What I'm suggesting to you when it says solve the system, what I'm saying is I think that maybe they meet somewhere, and how do I know where they meet? And if you think about where they meet where their x and y values are exactly the same at the same time, right? So let's take a look at this for a second. There are about three major ways to do this, and here's one of them. One is substitution. What I'm doing is when I look at the two equations, I'm trying to figure out what's the best method. And what I see here is that this second equation, let's call this equation down here, let's call this the second equation E2, and let's call this first one up here E1, the first equation. So I'm looking at the second equation here. I'm saying, look, this has a singular value of x. So what I could do is this. I could take this second equation right here and I could solve it for x. I could add negative 2y to both sides, right? That would be a legal algebra move, and I would end up with x is equal to negative 2y, right, plus 2. That's this negative 2y, and this is positive 2, so that's this positive 2 right here. So now what I'm saying is this. I'm saying I revised the first equations, the second equation, so now this one is just called RE2. Revised equation 2. I want to keep my equations in order here a little bit. And this is what I'm seeing here. This x right here, I'm saying in this first equation, I'm going to take the first equation, and where I find x in the first equation, I'm going to plug this in because it says here that x is this amount. So rewriting the first equation, we have 3 times x, right, plus 4y is equal to negative 4, right? All I'm doing is recopying this, right? And now what I'm going to do is this. I wonder if I'm able to do this. Let's try this. I'm going to take this piece right here, and then take this piece right here. It'd be great if I could have just picked that up. Okay, it didn't work. But you can see what I was trying to do. What I was trying to do is pick up this piece right here and put it right into here. So I'm going to put this, insert this right into here, and have negative 2y plus 2. And now you can see for the equation, the second equation here, I only have one variable. And if we were talking about calculus, we would say this is now possible because we could do this with single variable calculus. This is not calculus, but I just want to tell you where is this all going. So all I'm going to do here is I'm just going to distribute here into here. Remember, this still says 3x plus 4y. 3x plus 4y. Remember, in the second equation, x is this amount. I'm going to multiply this through. So 3 times negative 2y is negative 6y, isn't it? And 3 times positive 2 is positive 6. And then we're going to keep building what we already had. We had plus 4y, didn't we? So here's my plus 4y. Whoops. Plus 4y. 4y is equal to negative 4. Right, now we're going to simplify. So take your time here and simplify this out. Simplify this. We're going to, look, negative 6y's and positive 4y's is negative 2y. Remember, you can only add like terms. That is to say, you can't add it to 6 because this is not 6y's. This is 6 1's. So negative 6y's plus 4y's is equal to negative 2y's, right? It didn't use this positive 6 yet, so there's our positive 6 and negative 4. Now we just do some algebra, don't we? And we're going to solve, and we're going to find out what the value for y is. Add negative 6 to both sides here, and we get negative 2y is equal to negative 10. Divide both sides by negative 2, right? Because we want to figure out what the y value is. And we find out that y, that y is equal to negative over a negative is a positive. 10 over 2 is 5, so y equals 5. Right? Now what do? We take this value, right? Because remember, when we talked up here, we talked way up here, we said we're looking for the x and y where they match. Well, we have the y value now. This y is this y down here, isn't it? So this y is this y down here. So we have the point something 5. We know these equations meet there. I'm going to go back up here again to one of the equations. Oh, you know what I'm going to do here. This will be really easy. I know that y equals 5. I'm going to go to this second equation right here. If you don't mind, I'm going to put this in like this. Actually, I'm not even going to do it here. Let's do it here. So y equals 5, right? So y equals 5. If y equals 5, Well, then negative 2 times 5 is negative 10, and negative 10 plus 2 is negative 8, so x equals negative 8. So look, right, we are looking for the xy value where they match, and we know that it's negative 8. I'm sorry about this. It's negative 8. And last thing I want to show you is this. Let's go all the way back up here for a second, and let's see if this works out. We decided that this point right here is the point negative 8, 5, right? Negative 8, 5. We can go back and test this. 3 times negative 8 plus 4 times, whoops, did it backwards. No, I didn't. Negative 8 times, plus 4 times this 5, 5. So we have 3 times negative 8 is negative 24. 4 times 5 is 20. Negative 24 plus 20 is negative 4. So yes, that works. Let's see if this works. Oh, we already tested on the other one, didn't we? Because that's how we found this value. But we could try it again here if you want. We had x is negative 8. So negative 8 plus 2 times 5, right? 2 times 5. 2 times 5 is 10. 10 minus 8 is 2. It works. Okay? What we need to do is practice this a bunch of times. So go in your book and just remember what you're going to do is if you're going to use the substitution method, you're going to look and see can I solve one of my equations for either x or y and go from there. Keep working. This is something really, really worth knowing how to do. You're going to see this on the SAT.